Hello and welcome to the AI Cubed 3D Printing Discovery Lesson 1. This is the first part of a 5-part course where you will learn all about the exciting world of 3D printing, and this first lesson is just a taste to give you a bit of an overview about this exciting world and what you can expect in the next 4 lessons after this one. To start with, I'm going to give you a bit of an overview about who we are, AI Cubed, and then I'm going to take you on a bit of a journey about what you will expect in the next 4 lessons. For the last 4 years, AI Cubed have been developing inspiring content to take students aged between 7 and 14 into the world of computer science, robotics, and design. Today's guide and introduction into 3D printing is our first free course that starts to let you have a look at all the possibilities that you could achieve in these worlds. And to let you know that you're in good hands, here is a list of some of the amazing results that our students had achieved in 2021, including a top 20 placing in the Oxford University Computing Challenge, Australian Informatics Olympiad medals, a silver and 3 bronze places, position 8 and 11 in the National RoboCup Rescue Line competition, and some achievements we're very proud of, which is first LEGO League national and now international finalists. And now a little summary about what you'll find in the other lessons that follow this one, lessons 2 to 5. So today's introduction we'll get into in a minute. It's just a small snapshot about the world of 3D printing, some of the terms, some of the technologies, some of the things that can maybe demystify this world for you. Following this one, we have 4 excellent projects that will let you get started into designing your own 3D models and being able to print them. Now, importantly, you do not need access to a 3D printer to do this. We will provide you all of the way to set up your free software, how to design and create a 3D file that you can print, and then you can send it to us at AI Cubed. We will print it and deliver it to you. So it's a fantastic service and the best and lowest cost way for you to get started into 3D printing. The models that you can create all can be customized, so you can put your own little flair into them, and there really is a foolproof step-by-step guide that you can create them yourself. We can look more at that later, but let's get in today into part 1 and look at this overview of 3D printing. Okay. So let's have a look at our guide now, starting on page 3. And again, just a reminder that lesson 1 is just an overview about 3D printing, and your first project will start in lesson number 2. So on page 3, we have an overview about what is 3D printing. Well, really, the definition is pretty simple. It's being able to produce an actual physical model from a 3D computer file. And you will see exactly how that works and the different ways that we can do that. Page 4 introduces us to a really important concept when we're building our 3D models on our computers, and that's coordinates. When we start to create all of our models, we need to consider 3 coordinates. When we're building in 2 dimensions, we only need 2, which is the X, which is the horizontal plane, and the Y, which is the vertical plane. Of course, in 3D, we've got an extra one which we call Z, which is the forwards and backwards plane. There is a really easy way how to work out how those coordinates work when you're doing a model, and that's using your hand. We're going to use our right hand, and first of all, if you start by holding your fingers out, close 3 of your fingers so you've just got this shape, which is a bit of a right angle. You've got your pointer finger going straight up and your thumb pointing to the right. This is your y-axis and your x-axis. Then we have our middle finger, which I'm going to point straight towards me here, which is our z-axis. Now the reason this is important is this always tells you the positive direction of each axis. If you look at the y, which is going up, is positive. Going down will be negative or a minus number. The x-axis that points to the right means anything traveling to the right of our screen will be positive, anything going to the left of our screen will be negative, and the z-axis is pointing towards us, So anything that goes this direction towards us or out of your screen is positive, and away from you is negative. These are pretty consistent coordinates that are used in a lot of 3D modeling and used in all different types of 3D modeling software, which we'll look at in a moment. Page 5 and 6 takes us through all the different main types of 3D printers. I'm not going to go through all of them. I'll let you read the guide yourself, but let's focus on the first one, which is the most common type of 3D printer, and also the one that we're going to be using to print your models later on. This is called an FDM printer, which stands for a Fused Deposition Modeling. Let's work out what that means. It's a very complicated name, a fairly easy process. Basically, what the printer does is prints layer upon layer by extruding, or just kind of heating up and squeezing out the plastic filament, which is the material, and it will print a very fine layer, and then print another layer and another layer, and it keeps building up until you have a final model. It's a pretty simple, efficient, and robust way of building a model, and it's really well suited for beginning projects and for being able to look at using some of our 3D models and giving us a pretty high percentage success rate. We'll talk about what can make a 3D print fail in a moment. So I'll let you read the other types of 3D printer models, and then we'll move on to our next section. Page 8 introduces us to the software that we'll use to create our models. And the one that we're going to be using is a very popular and free online service called Tinkercad. Now, Tinkercad is created by Autodesk, who create one of the world's most popular and widely used professional 3D modeling tools, which is called AutoCAD, which a lot of architects will use to design buildings. Tinkercad is a trimmed down version, but it has some special features that allow us to create models and convert them into 3D printing files. We'll learn more about the actual file format that we need to save them later, but in lesson 2 you will go through a complete guide to how to set up your own Tinkercad account and how to start using the basics to create your very first model. On page 10 we start to look at the filaments, which is the type of material that actually goes into printing our 3D models. Again, there are lots of different formats, and I'll let you read about a couple of the popular ones on page 10, but I'll just touch on the one that again we'll be using in our models, which is called PLA, or a polylactic acid. So it's a very popular one because it's a fairly robust material. It heats up really well and consistently, and can create really nice models. The other thing, and you don't have to worry about this as well, but it doesn't give off an odor and is pretty safe for humans, which is really important when we're working with our models. The files that we're going to create are a very popular industry standard format called an STL file. Now, an STL file is not only for 3D printing, but it can be used in virtual reality, in games, in lots of other environments as well. But this format translates really well to printing, and it converts our file, our 3D file. When we put it onto our printer, it'll break it down into layers ready for printing each of those layers we talked about. So the STL file, again in lesson 2, you will learn how to save your project in this format, and then you can send it to us and we will print your file for you. It's important to remember that when you save your project in this format and you send it, the receiver, like us, can't edit it anymore. So you have to make sure that you're very happy that it's final and there are no mistakes, because it will be printed exactly how we receive it. You'll learn more about that in lesson 2. The last thing I'll talk about today in our guide, and again I'm going to let you read most of it yourself, it's just the finishing process, and in particular what we call adding supports. So supports are really important to make sure our prints don't fail. There's a few really basics about learning about printing supports and 3D model files. Number one is you always want to print it on a flat plane. So the most flat surface of the object is on a flat surface. If we print something on an angle, it may fail and fall over, or the printing head might not be able to print the lines very fine. So that's important. If we do have something that's going to overhang, like in our example here, you can see we've got three letters, Y, H, and T. They're all formed slightly different, but you can see on the Y, if we were starting at the bottom printing up, we would start to print some overhang. And then on the T, we would definitely have overhang. So what we need to do in that case is print what we call a support to make sure that as we're printing, for example, the top of the T, that all of that space underneath, the printer can't print in midair. So we'd have to create almost like scaffolding on a building site to make sure it's supported well. And then afterwards, we can break that material off and we can sand it with some sandpaper to get our finish nice and clean. So you'll learn about the different types of supports. And again, we've tried to set up your projects so we give you all of the guidelines how to create them, and we make them with the best possibility of low failure. But you will learn the more you print, the more designs you build, you'll start to visually see which ones require support material and which ones don't. Now, the good thing about support material is you do not have to build it in to your model. After you create your STL file, your 3D model file, and you send it to us, we will actually be able to add the supports, which is part of the software that comes with the printer. It'll have a look at the overhang and it will make some supports for it automatically. You can, of course, add them yourself, but we will let you know in the guides when that's necessary. So I hope you've enjoyed hearing a little bit more detail about some of the things in your guide, and that you read through it and you can discover some new terms maybe you've heard before and didn't understand, or completely new terms that you're not familiar with, and it gives you a bit more confidence about the process. In lesson 2, which hopefully you can download now, or you already have downloaded, you will start to build your own project. And again, this is another free guide. We show you how to set up your software, the Tinkercad we talked about, how to create a basic shape, how to move it around, add some customizations like 3D text, and then save it into a file format ready for printing. So good luck. I look forward to seeing your projects, and we will see you in lesson 2. Thank you.